Hello everyone, welcome back to TMLS 2021. My name is Nadia and I'm a senior machine learning engineer, and today I'm very honored to be here and to have the opportunity to introduce two of our amazing speakers. Before starting, I would like to remind you all that you can post your question in the chat. Please do it meanwhile they are talking, so at the end I can ask those questions to our speakers. Our speakers for this session are Palermo Penano and Kenneth Lau. Palermo Penano is a senior data scientist at Scotiabank International Bank Analytic Team. He is experienced in building end-to-end machine learning solutions for financial services with use cases ranging from customer attrition, campaign optimization and lead allocation, and loan and deposit pricing. He has a master's degree in economics from the University of Toronto. Kenneth Lau received his master's degree in data science at Simon Fraser University. In the past, he worked with Vancity Credit Union to build machine learning models and visualization to support banking operation. Currently, Kenneth works as a data scientist at Scotiabank, where he builds and develops end-to-end machine learning products for retail and commercial banking. Please join me welcoming Palermo Penano and Kenneth Lau.
Hi, everyone. Thank you, Nadia, for that introduction. Okay, so we'll jump right into it. So again, my name is Palermo, and this presentation is about building machine learning pipelines in Airflow with Jupyter notebooks. So, this is probably better as a workshop, but our goal for this presentation was to basically give a high-level overview of how we schedule, workflows, particularly like machine learning pipelines using Airflow that we built using Jupyter notebooks. And our goal is to hopefully this will serve as a useful reference for anyone who may want to implement a similar workflow for their use cases. Now, our main motivation for why we decided to do this is, as everyone's fully aware, Jupyter notebooks are a very popular tool for data scientists. We use them a lot in our work. So then one time we were thinking, like, how can we, kind of make the transition between model development and productionization of our model a little bit more seamless, right? So specifically, the question we had in mind is, how can we productionize our machine learning models using the most popular tool used by data scientists, which are Jupyter notebooks? And on our research, we came across two great blog posts by Netflix, one on how they use notebooks at Netflix, and two on how they schedule their notebooks, so that they can productionize their models. So those two articles are very inspiring for us. The agenda for the talk is I'm just going to go over briefly about machine learning pipelines and distinguish it from machine learning development, particularly. The second point is to just go over Jupyter notebooks. So I'm sure everyone in this audience is already very familiar with what notebooks are, but I'm just going to talk about briefly about what they're great for and what they're not so great for. And following that, we're going to go over how we implement like these pipelines of notebooks using general work orchestration tool or workflow orchestration tool called Airflow. Specifically, one of the more useful libraries that we need that is critical for this is a library called Papermill, which allows us to parameterize our notebooks and execute them. I found this really great diagram from a course I took a while back about machine learning development lifecycle. And as many of you are aware, it's not a linear process from beginning to end. You'll have like situations where you're planning your projects, and then you get to the data collection phase, and you learn something about your data set, and you realize that you need to go back to your planning and scoping and adjust the scope of the project because of some limitation in the data set. And it could even be something where you're training your model and you notice some bug, which is related to some data you've collected, which also allows you to discover that perhaps like the hypothesis that you had in mind or the model you're trying to train is not possible. So then you'd have to readjust your scope and so on. So this would be like the development lifecycle for a machine learning use case typically. But what we're more interested in is a machine learning pipeline. So a pipeline could be generally described as a sequence of code for the purpose of obtaining some desired outcome at the end, right? So in this case, there are two very common pipelines in machine learning. One is the training pipeline, and the other is the inference pipeline. In the training pipeline, you might have a process where you would load the data and then apply some like cleaning to it. It may be some filter that you need to apply to the SQL query, where you want to just select a subset of the population you want to build your model for, and then you'll do some pre-processing on that data set, or otherwise called as feature engineering. And then you'll have some step to like generate your training and data set and split it from your validation data set. And then you might have a model that you've, during your development of this model that you have settled on. So maybe this is like some random forest model that you want to train. And then you might have a step for evaluating the model. And then finally, you want to upload the model to some storage space on a server somewhere to save it, so that you can then, following that, run your inference pipeline, right? So then your inference pipeline is slightly different, but there are similar components. So you would load your data, and then you would apply a very similar cleaning and pre-processing step that you've used when you trained your model. And then the thing where it's different is now instead of training a new model, you would load the model that you trained. And then using the data that you've cleaned, you would generate like the scores, for example. So if it's a regression problem, this could be like a data set of like continuous values for every customer. Perhaps it's like the probability that they'll accept a loan, in our case, for some of our use cases. You may then apply some like post-processing on that data set. So perhaps like it would be more digestible by your business stakeholders if you were to like bucket the scores into like 10 into deciles, for example. And then finally, you could either, you would either save that file or like upload it to like an SQL table, perhaps, for consumption. So this is a machine learning pipeline. Now, what are Jupyter notebooks? Well, Jupyter notebooks are, just reading this quote here, it's an open source interactive web tool, that combines software, computational output, exploratory text, and multimedia resources in a single document. So for me personally, I find them great because of like the intuitive interface for exploring data and for model development. They're especially exceptional for, generating visualization and iterating on it, right? But they may not be so great for things like, for example, you cannot parameterize notebooks. And I will explain this more in greater detail once we start like talking about Papermill. It's a little difficult to execute them in a pipeline. So, maybe like one way you would do that, if you didn't have the right tools for the job, maybe like you'd have to open each individual notebook and then like run them in a sequence. And that could like introduce some bugs, and it's a little cumbersome to like have to manage all these browser tabs for your different notebooks. They're not so easy to debug as well compared to like code that's maybe written in text files. And additionally, they're also very difficult to version control. Compared to like code and text files, there are tools for that, like extensions in Jupyter called like NBDiff, but relative to text files, I just find them a little bit more difficult to version control. This talk in particular addresses, since we're talking about like machine learning pipelines, right? We're gonna specifically, focus on the solutions around these two drawbacks for notebooks, which is like, parameterizing notebooks and also some kind of workflow to allow us to execute them into a pipeline that we explained in the previous slide, similar to the one we explained in the previous slide. Okay, so then in the next part of our presentation, we'll talk about like how we create these pipelines and notebooks with Airflow, right? So one of the very important libraries that we used to be able to do this is called Papermill. So Papermill is a library. I have a link here for it if you're curious, for parameterizing and executing notebooks. What they're very great for is that they provide a command line and a Python interface for running the notebooks. This is, in terms of the command line, it's similar to a command that you might be familiar with called Jupyter NB-convert. But what's great with the Papermill is that, it manages its own runtime process. Additionally, in terms of like the input, all you'd have to do is provide it with like a source notebook that you want to run, along with the parameter values that you want to run the notebook for. So for example, these values could be, say, you want to produce, some kind of financial report for like different months. So it could be like the month and the year, for example, or perhaps it could be like filters that you want to apply to a subset to your data. And then it'll produce like an output notebook that will not mutate your original notebook, but the output notebook will basically contain the output of this notebook, right, after you have run it using the parameters that you've provided, right? And you can upload that output notebook then to a database or some storage space that you can then review, right, afterwards. So then now I'm going to pass it on to Kenneth to explain like the rest of the workflow.
Thank you, Palermo. Now, diving straight into the notebooks, it's important to see how to configure them with respect to Papermill. So the input notebook, which is the image that you see on the top, in order to utilize Papermill, one needs to create a cell with a value that you essentially want to parameterize for the workflow. And next, you'd like to select said cell and navigate to the property inspector, which can be found on the left side of the notebook, highlighted in the red. So it would be the gears. And what you'd like to do is type in parameters in that add tag box. And what this essentially does is that it marks that specific cell for Papermill to parameterize on. Now, after executing the Papermill command, it'll run each cell in the notebook without having it opened. And as Papermill runs the cell with the parameter tag, what it'll do is that it'll insert a new cell tagged as injected parameters immediately after that parameter cell. And what this essentially does is that it overrides the variable value. And the subsequent cells are then treated as normal, And next slide. And on this slide, you can see the CLI of Papermill, where it's a screenshot of a shell script. And so the intent of the shell script is to run the various notebooks utilizing Papermill. The notebooks are run in a sequence starting from download data from SQL notebook all the way to the upload output to SQL notebook. In order to execute Papermill, one can simply run the following commands, where the first argument can be the path of the input notebook. The second argument is the path for the output notebook, and the -Ps refer to the parameter names and its respective values. So in our case, our parameters are the months as well as our utility path. And by executing the Papermill function, as Palermo had indicated, what it'll do is it will run the input notebook with the updated parameters. Next slide, please. Now, with respects to productionizing Papermill, the Papermill pipeline on Airflow, we first need to understand what Papermill is. And so Papermill is an open source platform to author, schedule, and monitor workflows. And it has many benefits. It has its own UI where one can easily visualize the data pipelines, the dependencies, the progress, the logs, the code, as well as trigger tasks all under one roof. The Airflow pipeline is designed under the principles of configuration as code and is defined as Python scripts, which allows for dynamic pipeline generation. And the final advantage that I want to mention with regards to Airflow is that it's scalable. So users are able to allocate the necessary resources to run their pipeline, whether if it's a simple one or a complex pipeline. Next slide, please. Now, digging a little bit deeper into how Airflow executes the pipeline, Airflow utilizes a direct acyclic graph, or a DAG, to manage the workflow orchestration. And so a DAG is a collection of all tasks that you'd like to run, organized in a way that reflects their relationships and dependencies. And so a simple example of a DAG could consist of 3 tasks: task A, task B, and task C. And you can say that task A has to run successfully before task B, and then task B has to run successfully before task C. So it's very simple. However, you can create it as complex as you want. So another example would be task A having to run successfully before task B, but task C can run at any time. Essentially, what I'm trying to say here is that a DAG describes how you would want to carry out your own pipeline or workflow. And to instantiate a DAG, you need to have 2 parameters in the DAG, which is the DAG name, or the DAG ID, as well as the schedule interval. And so the DAG ID is the unique identifier of the DAG across all DAGs, and the schedule interval just allocates a set schedule or time in which to run the DAG. So you can have it set to monthly, weekly, bi-weekly, yearly. You can set it up for one use, or you don't need to set it up at all. And then following the DAG, you have the task. And the tasks are the basic units of execution within Airflow. And within the task, you need to specify a few variables. And these few variables are the task name, the operator, and the arguments. So the task name is the unique identifier in the DAG that helps you manage how tasks are run. The operator determines what actually executes when your DAG runs. So it can be a bash operator, a Python operator, MySQL operator, or some other type of operator as well. It just depends on how you like to set up your DAG. And then finally, there is the arguments, which is just simply the arguments that you'd like to run. And in our case, in the image that you can see at the bottom right, this is how we wanted to set up our DAG, where we wanted it to run on a monthly basis. And for the task in this DAG, we used the Kubernetes pod operator because we have Airflow running on the Kubernetes cluster. And since we're running Airflow on a cluster, we have to specify the resources necessary in order for the task to run. And finally, the task needs access to a volley amount, so we're able to store the outputs from the arguments. And as for the arguments themselves, they're structured in a very similar way to executing Papermill on JupyterHub, where we first need to use the Papermill command and then pass in the path in the target notebook, pass in the path for the output notebook, and include any parameters with its respected value. Next slide, please. Now, with respects to Airflow, once the DAG has been configured appropriately, you're able to take a look into the Airflow UI. And so with the Airflow UI, you're able to visualize, monitor, and even troubleshoot a data pipeline. And there are essentially 2 views that I want to talk about in particular. And the first one is the graph view. So the graph view essentially visualizes the DAG dependencies and their current status for a specific run. So you can kind of see in this screenshot, and if you can recall where Palermo was talking about the inference pipeline, we were able to apply a set approach where we load the data from SQL, perform pre-processing, load the model, and then generate the inference pipeline, followed by the post-processing, and finally the upload output to SQL notebook, or the task. And so what I actually wanted to highlight in this slide in particular is that anyone is able to run a task in parallel, as seen with the download data from SQL and the cleaning and pre-processing task in comparison to the load model task. Yes. Next slide, please. And the final view within the Airflow UI that I'd like to speak about is the tree view. So the tree view historically shows the DAG's previous runs as well as its current run. And this is quite important because you're able to see all the errors within the pipeline that had occurred previously. So then you're able to do additional debugging in order to configure and fix said task. One important feature within the tree view is that you're able to start the pipeline at any given task. And this is important when it comes to debugging them. So let's say that there's an error in the post-processing task. So once you're able to fix the error within the task, you're able to restart the pipeline from that task as opposed to running the entire DAG themselves. Next slide, please. And so with regards to creating pipelines, there are many advantages, as we previously had mentioned. However, there are some common challenges that we need to address. Version controlling notebooks is problematic, as Palermo had mentioned. However, fortunately, there are resources that enable users to address the problem, such as the NVDIME. With respects to debugging notebooks, it can be entirely challenging in comparison to code development in text files. So users that encounter errors within a pipeline, they would essentially have to run each cell within a particular notebook to see if there's any errors, as opposed to code development text files where the text file would then essentially tell you where the code breaks. Users can step through the code when debugging in the text file using debugging tools, so that's quite important. And finally, the last thing that we want to mention is that, and this is in particular with Airflow, is that it might be particularly challenging to set up if you don't actually have any previous experience setting up machine learning pipelines. So this requires, for setting up Airflow, it has a higher technical overhead above what a data scientist should do as a task. And this might require the support from a machine learning or a DevOps team. With that being said, that is the end of our presentation. Are there any questions?
Thank you so much to both of you for this amazing presentation. Yes, we have quite a few questions. So I'll start with the first one. Okay, so there is some people that are asking if you could share the two links that you presented in the first slide, the one from Netflix, and if you can post them in the chat. So this one was more like an housekeeping thing. So let's start with the first question. On testing, do you test it among yourself, or you have professional tester with background in AI ML? Are you following software development delivery methodology like Agile, Waterfall, or hybrid?
Yeah, so I guess I kind of answered the questions in the chat already, but yeah, we do the testing ourselves. So the way every individual who's assigned to a use case would implement these pipelines themselves and do the testing themselves. But we do have some people, data scientists in the team with more machine learning engineering background to help us test or debug more complicated issues. And in terms of our our workflow and how the team is organized, we do follow Agile.
Perfect. Thank you so much. Next question is, in which case do you recommend to use this approach?
Yeah, so this is a very general methodology for organizing machine learning pipelines or any data science use case pipelines that you've developed using notebooks that you want to schedule, right? So it could be as simple as maybe you want to generate some reports that you've created using notebooks that then you want to reproduce on a regular basis on a schedule, right? Or it could be something as complicated as a full-blown end-to-end machine learning use case that has a very complicated workflow that maybe a model that needs to be trained every quarter and subsequently have the inference pipeline produced or the scores produced, right, monthly, for example. So there's no specific use case that we're applying this for. Obviously, the use cases we're applying it for is related to financial services, but you could use it for any use case.
Thank you so much. Next question is, are you work on Papermill or on the cloud?
Scotiabank has a set up an infrastructure. So it's on-prem. It's cloud from our perspective, right? But it's implemented on Scotiabank on a cluster that belongs to Scotiabank.
Thank you so much. And next one. Is this talk documented somewhere as a tutorial, or could you recommend any tutorial?
We don't have any tutorials that, well, I mean, we have some internally, that's created by the team for how to, for people who wants to use it within the team. So I think the Netflix blog posts are great, although they're also a little high level, but I think it's a great starting point.
Perfect, thank you. We still have 2 questions. Can this set up several real-time requests via the pipeline? Something like an endpoint instead of load data from SQL step?
Sorry, I'm just trying to read the question. Okay.
Yeah, I think they're asking if you can switch one of the steps with an API request.
You should be able to, yeah, because in one of the slides, if I understand the question, let's see. So, anything that you could run in a, the command line, for example, oh, I can't see my mouse, right? You would just, state that here, right? So if you want to make an API request to load data from some some endpoint, you would just put that command here, right? Or you can do it in one of the notebooks, right, and then run the notebooks using Papermill if you wish. With the advantage of using the notebooks is that you would be able to produce maybe some descriptive statistics, right, that would then be saved in the output notebook that you can then review, right, to check your data. So yeah, there's a lot of flexibility in terms of how you want to do it.
Awesome, thank you. So next question is more related to roadblocks. Can you talk a little bit more about the biggest roadblock overhead with setting up this workflow?
I'll give this one to Kenneth.
Yeah. So with regard to the roadblocks that I had encountered setting up this workflow, a lot of it comes down to pathing. So the tasks themselves, they're independent from each other. And so like a lot of my outputs for each notebook in general would not transition to the next task. And as a result, we needed to figure out a way to find a method to access those those outputs from those tasks. And so we needed to make sure that our pathing is correct, and the fact that we also need to utilize volume mounts in order for us to access them appropriately. So high level, it's just a lot of my issues comes down to making sure that my pathing was set appropriately in order to successfully run my DAG.
And just to add to that, I mean, it's one of those things where it's difficult initially, and it was difficult for our team as well because it's a relatively new system for us. But the way to do it with subsequent use cases, obviously, it gets easier over time. So because the template is or like the approach is pretty standard, it doesn't change.
Thank you so much to both of you. Next question is on versioning control. I heard the versioning control is challenging in Jupyter. I might have missed it, but what's your versioning recommendation?
Yeah, sure. So there's an extension called NBDime, which if when you install it, it'll you'll see like a button on your Jupyter notebook, like Git. And then that would open a browser and show you the cell by cell difference between your current code and the part of the code that's been that's been staged, for example. So it's called NBDime, and that's what we use. I'm gonna look for it. I think I have a link here for the extension, but I can't find it. It's in the slide somewhere.
Okay, thank you so much. Next question is related to testing instead. What kind of testing strategies, techniques do you use for this kind of inference pipeline, like unit testing, integration testing, and performance testing, or tool like PyTest that could be integrated nicely with this use case?
Like unit testing, integration testing. Yeah, so that's an area that's still exploring at the moment. So right now, we're kind of like this is kind of like a we've implemented this on like pilot use cases. That's not like necessarily deployed on like a production server. So this is still it's kind of in a way a little bit experimental. So I don't really have a good answer to that question at the moment. But I imagine like teams with more experience who have used using Airflow for build pipelines will have some process to yeah.
Thank you so much
for this.
Yeah. Next question is, do you guys push your code to production? If yes, do you push notebook or Python files?
Yeah, so for productionization, it will be just notebooks, right? So that's the whole idea. So we're using the notebooks to productionize the models. I mean, we have use cases where we just use like .py files for sure, but we're again, like as I said, we're experimenting with this approach, given that we use notebooks extensively, and it reduces like the basically like the steps between model development and then productionization, because then you wouldn't need to like refactor your code in between. You would just like kind of develop your pipeline as you're developing your model.
Thanks. Next one is, how complicated do things when utilizing Airflow on big data workflows, maybe using a Spark operator? Any issue with the scaling or data retrieving?
We have people in the team who've used Spark with Airflow. I personally don't have firsthand experience with that, so I don't have a good answer for that question, unfortunately.
Fair. Next one, we still have two questions. So many questions. This
keep them coming.
Is really popular, so I will keep going till I see interesting question. How do ML experiment tracking tools like MLflow for example, work with this approach?
Yeah, I've heard of MLflow, but that's like kind of the next step in our experiment, which is to integrate like these tracking tools. So I also don't have a good answer for that question, but I can't imagine it being like, I can't imagine it not being possible, right? Or imagine it being possible. So yeah, I don't have a good answer for that for now.
Yeah, I never work with Airflow, but I work with MLflow, and it's a Python library. And practically, I guess you will lose the UI that is really nice, but the tracking would happen without issues.
Yeah, if like the what do you call it? Like the model performance, if they're documented in a text file or something, as opposed to like a web UI, then obviously you could use this approach. With Airflow, you would just save the logs effectively in one of your pipelines, like during training, and then review them afterwards.
Okay, so we have the last question finally. If you could redo this process with the knowledge you have now, what would you change about your workflow or setup process? This is an interesting one.
Yeah, and I agree. What would you change about your workflow or setup process? That's a good question. I mean, we didn't have to set up Airflow ourselves, so we have like a DevOps team who kind of helped us with this. So yeah, I feel like somebody who is an ML engineer who actually implemented like the infrastructure for Airflow would have a better answer about like what could change. So I mean, if you could redo the process, I don't know. Yeah, I don't have a good answer. I mean, it's like we're still kind of new to this approach, so it's like I feel like we need some more time to like use it and to be able to reflect on like the things that we would change. So far, it's like it's been working pretty well for us. Yeah, I'm sorry, I'm not sure if that helps.
That's fine. There is another person that is handling this stuff, so you're not supposed to know what is not in your job. So thank you so much, guys. It was really interesting to see how to integrate an MLOps tool with a Jupyter notebook, and it seems a lot of people found it interesting as well, seeing the high number of questions we got. But thank you so much for staying here to answer all of them, and have a good rest of your day.
Thank you, Nadia, and thank you, everyone, for letting us present.
Thank you, everyone.
Bye.